Hello everyone. So today we are gonna discuss internal 2 paper 1. So let's begin. So the first question is to discuss attribute by attribute problems that we have found into following database. The database given here contains customer ID, ZIP, gender, income, age, marital status, and transaction. So let us discuss attribute by attribute some of the problems that we have found their way into the data set. The customer ID variable seems to be fine. Here, all the customer IDs are in numeric values. That seems to be fine. Attribute of zip. Here we are expecting all of the customer in the database to have usual 5 numeral US zip code. That is, all the elements of the zip attribute should contain numerical value. But as we can see in 1002 customer ID that we have alphanumeric value. So the customer 1002 has zip code of this unusual value may be an error and toss it out. So actually this is the zip of the so this zip code contains a problem. Okay. 1003 zip code is okay. Now let's see the others. For customer 1004, we are unaware of any countries that have 4-digit zip codes such as 6269 indicated here. So this must be an error, right? Probably not. Zip codes for New Zealand, New England states begin with numeral 0 unless the zip code field is defined to be character or text and not numeric. The software will probably chop off the leading 0, which is apparently what happened here. So zip code would be 06269. Okay. And now let's check for the gender. Gender attribute contains a missing value for customer 1003, and the income field is measuring annual gross income, has 3 potentially anomalous values. Customer 1003 income of dollar this per year. Possible, especially when considering the customer's zip code 902 Beverly Hills. This value of income is nevertheless an outlier and extreme data value. Certain statistical and data mining modeling techniques do not function smoothly in presence of outliers. And customer 1004's reported income of $40,000 lies beyond the field bounds for income and therefore must be an error. And customer 1005's income of $99,999, perhaps it may in fact be valid, but if all the other incomes are rounded to nearest $5,000, why the precision with customer 1005? The age field has a couple of problems, although all the other customer have numerical values for age. The customer of C probably reflects earlier categorization of this man's age to a labeled C. The data mining software will the data mining software will definitely not like this categorical value, otherwise numerical field, and we will also have the same problem. Customers 1004 age of 0, perhaps there is newborn male living in store. The age of this person is probably missing and was coded to 0 to indicate this or some other another. Of course, keeping the age field in database is a minefield in itself, since the passage of time will quickly make the field values absolute, and it is better to keep date type field. The marital status field seems fine. The problem lies in meaning behind these symbols. We all think we know these symbols, but are sometimes surprised. For example, cold water in a restroom in Montreal and S for customer 1003 and stand for single or separated. This can be a question. Transaction amount field seems satisfactory as long as we are confident that we know what unit of measure. Question 2. Apply data wrangling process in following database. Data wrangling process. All names are now formatted the same way, that is first name then last name. So here given name we can see Jagdish Singh, Jain Tilak. So we'll convert Jain Tilak into Tilak Jain, and Gupta Binod into Binod Gupta, Arun Fakira, and Jackie Agrawal. Now phone number are also formatted the same way, area code ABC XXX. So we can see here, first is the area code and then the number. Dates are formatted numerically, that is year first, then month, then day. So we can write it as 1979. Month would be January, February, March, April, May, June, July, August. Month is 8. So we can write it as 1979 08 12. And we can write all of these like that. And the states are not abbreviated. The entry of Jackie Agrawal did not have fully formatted the area code. It had, because it had no year, so it was discarded from the data wrangling. From the data. Now that resulting data set is cleaned, readable for deployment or evaluation. So we can see here we have written Jagdish Singh, Tilak Jain, Binod Gupta, and Arun Fakira. We have written the phone number as country code and then number. We have written birth date as year, month, and date, and we have written the state. Question 3 says, consider the following database, apply any three methods for finding out missing values. So the three methods are with user-defined constants, with mean and mode, and the third is with random draws from the distribution of the variable. So here we are replacing missing field value with user-defined constants. So this value will be 0, and here we'll write missing. This is missing and this is 0. Replacing missing field values with mean or mode. So what we do here is we take the mean of these number and divide it by 4, and here we take the mode of these values, that is which value is coming the most. So we can see Ujjain is coming 2 times, so here we write Ujjain, and the mean of these numbers would be 200.65, so that's why we have written here 200.65. Replacing missing field values with random draws from the distribution of the variable. So from these values we can pick any value and we can put it here, and also from here we can pick any value and we can put it here. That's it. So the fourth question is, classify bank loan application by assigning application to one of the three classes. So we are given a table and we have to find information gain from this table. So we have number of example as S. So we can see S is equal to 10. We have 10 number of rows. Number of classes 3. We can see A, B, and C. So frequency of class A is 3, frequency of class B is 3, and C, as we can count here, there are 4 C's. Overall information in the given data due to uncertainty of outcome regarding the risk belongs to the given Y. So we have calculated the information gain of overall data, which can be calculated by minus A upon S log A upon S, minus B upon S log B upon S, minus C upon S log C upon S. This is the formula from which we got the value 1.57. Now we have taken attribute wise. So let's take attribute 1, owns home. We can see for value Y, there are 5 applicants who own home. They are in, we have A1, B2, and C2, and value of N, that is no. There are also 5 applicants, that is A2, B1, C2. So we check out the information gain of Y and information gain of N, and then we got 1.52 and 1.52. Then total information gain of the two subtrees would be 0.5 into 1 I of y plus 0.5 into I of n. That is 1.52. Now let's see attribute 2, that is married. We'll see the value y and we'll see the value n. For y we have a0, b1, c4. For n we have a3, b2, c0. Putting values together we get the values as 0.7222 and 0.971. So the total information gain we calculate by using this formula, that is we get 0.846. Now, attribute 3 is gender. We take the value of y, 3 applicants, A, B, C, where B is 3. And for n, we have 7 applicants, where A is 3 and C is 4 and B is 0. So calculating the value, we get I of y as 0 and I of n as 0.983. Then we calculate the total of subtrees and then we get the answer. Now, attribute 4 is employed. We check for y, there are 8 applicants, A3, B1, C4, and for n, there are 2 applicants, that is B equal to 2. We calculate that and we get 1.41 and 0. We check the total information of the two subtrees, that is 0.8. What we do is we divide this upon s, and s is 10. So when we divide 8 upon 10, so that's why we get 0.8 here. And when we divide 2 upon 10, that's why we get 0.2. Before also when we got 0.5, we got 5 upon 10, that is 0.5. So as you can see here, 0.8 I of y plus 0.2 I of n, the answer we got is 1.12. For credit rating, we did the same thing. 5 applicants, 2, 1, 2. 5 applicants, 1, 2, 2. We calculate the value. The answer is 1.52 for both. And the total information of both would be 1.52. Now, as we can see here, this is the attributes. This is information before split. That was the total information of overall data. That is 1.57. And information after split is this. So information gain we calculated by subtracting this. So as we can see in gender, we have the highest information gain. So now we can reduce the data by removing the attribute gender and removing the class B, since class B have gender male. As you can see, class B is removed. The information in this data of two classes due to uncertainty of outcome rather than class each person belongs to given by. Now we can see as 3 upon 7 log 3 upon 7 minus 5 upon minus 4 upon 7 log 4 upon 7, because we have removed the B class. So here we have A and C. There are 3A in gender and 4C. Okay, gender is removed. Let us now consider. Okay. So now again we do all this process for own home, where we have removed B. So we have only A and C. Calculating for A and C, we get 0.92 and 1. For married, we calculate, we get 0 and 0. The total information gain for homes is 0.96 and for this is 0. There is no need to consider other attribute now, because no other attribute could be better. The split attribute married will be used to split attribute. So as you can see, this is the decision tree. We have gender, that is on top. We have male with class B, and we have female who is married. Married is class C, that is yes, and who are not married are in class A. So this is how the decision trees are made. Compare the attribute for classification of bank loan application. Now we have to compare the attribute. The attribute comparison based on information gain. It is not necessarily always fair. This approach favors those attributes that have large number of values. So it does not favor those attributes that has only small amount of data. It deals in large amount of entries. So this approach favors, okay, if there was an attribute that had a large number of values such that each value resulted in only one element of the data set, then that attribute will be selected, although it might be an optimum split attribute in the data. It leads to wide tree with depth 1, quite inaccurate for unseen data.